This is linear algebra 10. This video is intended to support engineering students for their studies. This part of the module deals with engineering service examination, public sector examination, and engineering gate preparation. Also, I recommended the viewers to see the past videos of linear algebra from 1 to 8 in order to get a clear-cut idea. This linear algebra 10 is in continuation of linear algebra 9 in the Gate-2 coaching. Problem number 26. Let A equal to this matrix, A inverse equal to this matrix. Then find A plus B. A into A inverse equal to I. That is, this is A and this is A inverse and this is I. Then the matrix multiplication A into A inverse equal to this I. That is 3B equal to 1, B equal to 1 by 3. And 2A minus 0.1B equal to 0, we get A equal to 1 by 60. A equal to 1 by 60, B equal to 1 by 3, we get A plus B equal to 7 by 20. That is answer A. Then 27th question. Consider a non-homogeneous system of linear equation representing mathematically an overdetermined system. Such a system will be, this is A, this is B, this is C, and this is D. Then consisting have a unique solution. This is true, A is true. Consistent having a unique solution. Consisting having many solutions. That is rank of AB less than number of unknown, then consistent having many solutions. Inconsistent having a unique solution. It is not possible. That is C is wrong. Inconsistent having no solution. That is also correct. That is in this question A, B and D are all possible. C is not possible. Then question number 28. A is a 3 by 4 real matrix and Ax equal to B is inconsistent system of equation. Ax equal to B is inconsistent. The highest possible rank of A is, rank of A is a 3, R is a 3 by 4 matrix. R is a 3 by 4 matrix. Then rank of A is a 3 by 4 matrix. Then rank of A less than or equal to minimum of 3 and 4, minimum of rows and column. That is rank of A less than or equal to 3. And rank of AB equal to, A is 3 by 4, A is 3 by 4. And AB equal to a 3 by 5 matrix. Additional column is added. And AB, rank of AB equal to less than or equal to row and column. That is rank of AB equal to less than or equal to 3. Rank of A less than or equal to 3 and rank of AB less than or equal to 3. If rank of A equal to 3 and rank of AB equal to 3, the system is consistent. Given that the system is inconsistent, that is rank of A not equal to rank of AB, but rank of AB equal to 3, then rank of A equal to 2. And rank of AB equal to 3. That is answer B is correct. Rank of A equal to 2. Rank of A equal to 2 and rank of AB equal to 3. Then we get inconsistent system. The system is inconsistent. Then question number 29. In the metric equation Px equal to Q, which of the following is necessary? A. Augmented matrix PQ must have same rank as P. This is correct. These three are not correct. That is rank of PQ equal to rank of P. That is answer A is correct. Then problem number 30. Consider the following system of equation in three variable x1, x2, x3. This is the first equation. This is the second equation. This is the third equation. This equation has no solution, unique solution, more than but finite number of solution, and infinite number of solution. Here, the augmented matrix of this equation, augmented matrix of this three equation is equal to, this is the augmented matrix, which is reduced to be in the row echelon form. This is the row echelon form of AB. Then rank of A, this is the row echelon form, rank of A equal to 3. Rank of AB is also equal to 3. Rank of A equal to 3, rank of AB equal to 3, that is also equal to number of variable. Hence, this equation has a unique solution. That is answer B is correct. Unique solution. Number 31. Which one of the following is an eigenvector of the matrix this? The eigenvalue problem. Determinant of A minus lambda I. This is A minus lambda I is equal to this. That is equal to 0. Is the characteristic equation. That is, this is equation. These are 0. Then 5 minus lambda into this also. 5 minus lambda. This 0. 5 minus lambda into 2 minus the determinant of this matrix. That is 2 minus lambda into 1 minus lambda minus 1 into 3 equal to 0. This is the characteristic equation. Solving this equation, we get lambda equal to 5, 5 and 3 plus root 3 by root 13 by 2 and 3 minus root 13 by 2. Put lambda equal to 5 in this equation. Lambda equal to 5 in this characteristic equation. Lambda equal to 5. Lambda equal to 5 in this equation. We get this matrix equation. Lambda equal to 5 in the this matrix equation. This we get the eigenvalue, eigenvector. That is, this can be, that is lambda, this can be reduced to be this. That is on substitution. That is, this is equal to 0, 0 x1 plus 0 x2 plus 5 x3 plus 0 x4 equal to, that is x3 equal to 0, x4 equal to 0, x2 equal to s, an arbitrary value, and s1 equal to r, another arbitrary value. Then the eigenvector corresponding lambda equal to 5 is equal to x1 equal to r, x1 equal to r, s2 equal to s, S3 equal to 0, S4 equal to 0. Put R equal to 1 and S equal to minus 1 in this equation. We get x1 equal to 1 minus 1, 0, 0. That is, in this x1, the last x3 and x4 equal to 0. That is, in the answer, there are given four answers. Only A, the last, in the column A, the last two x3 and x4 equal to 0 only in A. That is lambda equal to 5, we get one eigenvector x1 which is in A, which is equal to the answer A. Then we need not find the other eigenvectors corresponding to 3, this and this. That is lambda equal to 5, we get the correct answer. That is answer A is correct. Then problem 32. For the matrix A, one of the eigenvalues is equal to minus 2. Which of the following is an eigenvector? Eigenvector. This given matrix is upper triangular eigenvalues are diagonal elements, then lambda equal to 3 minus 2, 1. Then eigen vector is getting by a minus lambda ix equal to 0. That is put lambda equal to, that is this a minus lambda ix equal to 0, that is this. Put lambda equal to minus 2 in this equation, we get this. That is, these two are the pivot element. Take y equal to k, we get z equal to 0 and x equal to 2 by 5k. That is, eigenvector corresponding to lambda equal to minus 2 is x, y, z equal to 2 by 5, 1, 0, k. Put k equal to 1, we get x, y, z equal to 2 by 5, 1, 0. Multiplied by 5, we get x, y, z equal to 2, 5, 0. That is answer D. Lambda equal to eigenvector corresponding to lambda equal to minus 2 is equal to 2, 5, 0. Then question number 33. Given the matrix, the eigenvector is, that is, the characteristic equation of the matrix is equal to lambda square plus 2 lambda minus 20. That is lambda equal to minus 5 and 4. The eigenvalue problem, matrix of A minus lambda ix equal to 0 gives the eigenvectors. Put lambda equal to minus 5 in this equation. Lambda equal to minus 5 in this equation. We get this equation. It is reduced to row echelon form. That is, this is the row echelon form. This is the eigenvector corresponding to lambda equal to minus 5. Take y equal to k, then x equal to minus 2k. That is xy equal to minus 2, 1k. Put k equal to minus 1. We get xy or multiplied by minus 1. That is, put k equal to minus 1, we get xy equal to 2 minus 1, which is an eigenvector corresponding to lambda equal to minus 5. Eigenvector corresponding to lambda equal to minus 5. That is 2 minus 1. 2 minus 1. The 2 minus 1 is the eigenvector corresponding to lambda equal to minus 5. We already got the one answer. There is no need to find the next vector, eigenvector corresponding to lambda equal to 4. That is, answer is C. This is 2 minus 1 is the eigenvector corresponding to lambda equal to minus 5. Then problem 34. What are the eigenvalues of the following 2 by 2 matrix? The characteristic equation of this matrix is equal to lambda square minus 7 lambda plus 6 equal to 0. That is lambda equal to 1 over 6. That is answer B is correct. Then problem number 35. Multiplication of matrix E and F is G. Then what is the matrix E and G are? The multiplication of matrix E and F is G. Given E and G, find the value, find the matrix F. Given E and G, and E into F equal to G. What is the matrix F? Given that this is the matrix G, G is an identity matrix. G is an identity matrix, G equal to I. Given E into F equal to G, that is E into F equal to I. That is E into F equal to I implies F is equal to E inverse. E inverse. E inverse is equal to adjoint of E divided by determinant of E. Then find adjoint of E. That is a cofactor of E. This is E. This is E. The cofactor of E is equal to this. Then adjoint of E is equal to transpose of cofactor. That is, this is the transpose of cofactor. Transpose of cofactor. Then determinant of E is equal to determinant of E. Determinant of E, this E equal to 1. Then A inverse equal to adjoint of E divided by determinant of E. But determinant of E equal to 1. Then E inverse equal to adjoint of E. That is adjoint of E. That is E inverse equal to F. That is F equal to adjoint of E is this. F equal to this. That is answer C. Answer C. This is the correct answer. Next, problem number 36. Match the list 1 with the list 2 and select the correct answer using the code given below. 1. A. Singular matrix. Singular matrix is determinant equal to 0. Singular matrix is determinant equal to 0. Then non-square matrix. Non-square matrix is determinant not defined. This is true. Non-square matrix, square matrix determinant not defined. Then real symmetric matrix. The real symmetric matrix are eigenvalues are always real. Then orthogonal matrix. Orthogonal matrix is determinant is always 1. That is answer A is correct. Then 37th question. Rank of a matrix. Perform Gauss elimination. The matrix is reduced to be row echelon form. The rank is 2. Then rank is equal to 2. Answer C is correct. Then problem number 38. P equal to this, Q equal to this, R equal to this, are 3 vectors. An orthogonal set of vectors having a span that contain PQR. That is, we shall to find out the orthogonal vectors which span PQR. In we are looking for orthogonal vectors. Orthogonal vectors, the dot product are 0. For 2 vectors are orthogonal, its A transpose A is equal to 0. That is, if minus 6 into 4, minus 3 into minus 2, 6 into 3, that is equal to 0. That is, the 2 vectors are orthogonal. But these 2 matrices are not orthogonal. The dot product not equal to 0. C is not orthogonal. D is not orthogonal. That is, A is the correct orthogonal. In BCDR, their pairwise dot product not 0. That is not orthogonal. Then A. This is a vector. This is 2 vectors. These 2 vectors. The space spanned by these 2 vectors is equal to vector. First vector into R plus second vector into S. This span containing PQR. We have already get only one orthogonal vector. Where R is, which the answer is A. The answer is A. That is, the B, C, D are not orthogonal. Hence, answer A is correct. Then, with problem number 39. If the following vectors linearly depend upon a solution to the previous problem. In the previous problem, this minus 6, minus 3, 6, and 4 minus 2, 3. 4 minus 2, 3. This 2 vector together with which vector is linearly dependent? The vector 2. This and vector B is linearly dependent. Since these 3 vectors, this is a column vector, this is another column, this is another column. The determinant of this column, this matrix is equal to 0. that is determinant of equal to 0, that is the vectors are linearly dependent. The determinant of this matrix equal to 0, which means that the rank is less than 3. Either this rank is 1 or 2. If the rank is 1 or 2, then these three vectors are linearly dependent. The determinant equal to 0, which means that these three vectors are linearly dependent. That is, the answer B is correct. The vector B is linearly dependent. Linearly dependent with this two vector. Vector B is linearly dependent these two vectors, since these three vectors, the determinant of these three vectors equal to 0. Determinant of these three vectors equal to 0. We say that these three vectors are linearly dependent. Then problem number 40. Solution for system defined by set of equation. Then the augmented matrix AB equal to this, which is reduced to be row echelon form. This is the row echelon form of AB, augmented matrix AB. Then rank of A equal to 2, 1, 2. But rank of AB equal to 3. The system is inconsistent. That is, answer D is correct. The system is inconsistent. Next, problem 41. For the matrix, the eigenvalue corresponding to the eigenvector. This is the eigenvector. Eigenvector xy equal to xy equal to this. We shall to find the eigenvalue. The eigenvalue satisfies the characteristic equation A minus lambda I into x. That is A minus lambda I. This is A minus lambda I into x, the eigenvector, equal to 0. That is, this is the characteristic equation. This is the eigenvector. This characteristic equation, solve this characteristic equation, we get lambda equal to 6. That is, lambda equal to 6 is the eigenvalue corresponding to this eigenvector. That is answer C. That is, the eigenvector x satisfies the characteristic equation. This A minus lambda I x equal to 0. X is the eigenvector and lambda is the eigenvalue. Then problem number 42. For a given matrix, one of the eigenvalues is equal to 3. The other two eigenvalues are There is given that the eigenvalue, sum of the eigenvalue, one of the eigenvalues is equal to 3. That is lambda 1 plus lambda 2 plus lambda 3. That is the sum of the diagonal element, that is equal to 1. Sum of the diagonal elements. And given that lambda 1 equal to 3. That is lambda 2 plus lambda 3 is equal to minus 2. The answers are 2 minus 5. That is 2 and minus 5, the difference is equal to minus 3. It is not true. Then 3 minus 5, the difference is minus 2. That is the lambda 2 plus lambda 3 is equal to this. And C, the sum of the eigenvalue is equal to 7. This is sum of the eigenvalue is equal to 8. This is sum of the eigenvalue is equal to minus 2. And this sum of the eigenvalue is equal to minus 3. That is correct answer is B. Sum of the eigenvalue is equal to minus 2 is only B. That is B is the correct answer. Then 43. If the eigenvalues of the matrix S equal to 5 and 1. What is the eigenvalues of the matrix S square? S square is equal to S into S. We know that lambda 1, lambda 2, lambda n are the eigenvalues of A. Then lambda 1 power m, lambda 2 power m, lambda n power m are the eigenvalues of A power m. Hence, S square matrix has the eigenvalue 1 square. That is 1 and 5 square. that is 25. That is S square matrix has the eigenvalue of 1 square and 5 square. And that is answer A is correct. That is problem number 44. The eigenvalue corresponding to the eigenvector of a 2 by 2 matrix given by the eigenvalues lambda 1 equal to 8, lambda 2 equal to 4, and V1 equal to this, and V2 equal to this. The eigenvalues and the corresponding eigenvector. This is the eigenvalue. The eigenvalues are 8 and 4, and eigenvectors are V1 and V2. We shall to find out the which of the matrix have the eigenvalues 8 and 4. Then this matrix with the sum of the eigenvalues equal to 12. This is also 8 plus 4, 12. This sum of the eigenvalues is equal to 8. Here not, this is not true. The sum of the eigenvalues is equal to 4. This is not true. The sum of the eigenvalues is equal to 8. This is all not true. But sum of this eigenvalue is equal to 12. 8 plus 4, 12. That is A is the correct answer. Sum of the eigenvalues is equal to 12. It's the correct answer. Then A is a square matrix which is neither symmetric nor skew-symmetric, and A transpose is transpose. The sum of this matrix is A plus A transpose, and the difference is A minus A transpose respectively. Which of the statement is true? Which of the statement is true? That is, S is equal to A plus A transpose. S transpose is equal to A plus A transpose all transpose. That is equal to A transpose plus A transpose all transpose. That is equal to A. That is S transpose equal to S. That is S is symmetric. Then D transpose. D equal to A minus A transpose. D equal to this A minus A transpose. D transpose equal to A minus A transpose all transpose. That is equal to A transpose minus A. That is minus A minus of A minus A transpose. That is equal to minus D. That is D transpose equal to minus D. That is D is Q symmetric. That is answer D is correct. S is symmetric and D is Q symmetric. S equal to A plus A transpose and D equal to A minus A transpose. Then S is symmetric and D is Q symmetric, which is important. 6. The inverse of this matrix. That is, we shall to find the inverse. That is, we shall to find the inverse of ABCD is equal to 1 divided by AD minus BC into this. Hence, inverse of this matrix is equal to 1 by 1 into 7 minus 2 into 5. That is minus 3 into this. That is 1 by 3. That is 1 by 3 into minus 7, 5. That is this. This is the formula. This is a formula. This is the formula for the inverse, the 2 by 2 matrix. The inverse is this. Inverse of this. Hence, the inverse of this matrix is equal to this. That is this answer. A is correct. Then, problem number 47. X equal to x1, x2, xn transpose n tuple of non-zero vector. Then, n by n matrix V, there is V equal to x into x transpose. The rank the rank of this matrix. We shall to find out the rank of the matrix x into x transpose. This is X is equal to, this is a column matrix, that is rank of a column matrix. Rank of X is equal to, the by formula rank of X is equal to rank of X transpose. This is a column matrix, then X transpose is a row matrix. This has only one row. X transpose has only one row, then rank of xt equal to 1. That is rank of xt equal to 1 and rank of x equal to 1. Then rank of xxt by formula rank of xxt less than or equal to minimum of rank of x and rank of x transpose. That is equal to minimum of rank of x equal to 1 and rank of xt equal to 1. That is minimum of 1, 1, that is equal to 1. That is rank of xxt less than or equal to 1. That is rank of xxt less than or equal to 1 means rank of xxt equal to 0 or 1. But rank of xxt is not 0. Then x and xt are non-zero vectors. Then rank of xxt not equal to 0. Which implies that rank of xxt equal to 1. No, not equal to 0 is 1. Rank of xxt equal to 1. That is answer B is correct. Answer B is correct. Has rank 1. Then problem number 48. It is given that x1, x2, xm are m non-zero orthogonal vectors. Then the dimension of the vector space spanned by 2m vectors x1, x2, so on xm minus x1, minus x2, minus xm is. That is minus x1, minus x2 and minus xm are linearly dependent. Minus x1 is dependent to x1 and minus x2 is dependent to x2 and minus xm is dependent to xm. That is minus x1, minus x2 on minus xm are dependent of x1, x2, xm. That is x1, x2, xm and minus x1, minus x2 xm span the same vector space. That is this 2m vectors spanned by the same vector space which is spanned by x1, x2, so on xm. That is x1, x2, xm spanned by the vector space also equal to the vectors x1, x2, xm, minus x1, minus x2, minus xm. That is, these two vectors span the same vector space. That is, this vector space spanned by 2m vectors is equal to, the answer is C, that is M. This 2m vectors space spanned by the same vector space which is spanned by x1, x2. This dimension is M, hence this dimension is M, hence this dimension is also equal to M. Then problem number 49. For what values of alpha and beta, the following simultaneous equation has infinite number of solutions. Equation number 1, 2, 3. The augmented matrix of this equation is this, which is reduced to be row echelon form. This is the row echelon form. For infinite number of solution, rank of A equal to rank of AB equal to less than number of unknown. That is rank of A equal to rank of AB equal to, that is, this is equal to 0. Alpha minus 2 equals 0. And this is also equal to 0. B minus, that is alpha equal to 2 and beta equal to 7. That is, if alpha equal to 2 and beta equal to 7, then these two are equal to 0. Then rank is only 2. That is, answer is correct. A, alpha equal to 2, and beta equal to 7. This system of equation has infinite number of solutions. Then problem number 50. The number of linearly independent eigenvectors of this vector. The characteristic equation of this vector is equal to lambda square minus 4 lambda plus 4 equals 0. That is lambda equal to 2, 2. Then the eigenvalue problem a minus lambda ix equal to 0. Put lambda equal to 2 in this equation. Put lambda equal to, we get this equation. That is y. Okay. That is we get y equal to 0 and x equal to k. That is xy equal to 1k, 0k. That is we get only one linearly independent. This equation has only one linearly independent eigenvector. That is answer B is correct. Then problem number 51. The linear operator Lx is defined by Lx is the cross product of B and X, where B equal to this a column matrix and X is equal to this another column matrix. Then this operation satisfies this Bx satisfies M into, that is M is a 3 by 3 matrix, that is this Lx satisfies M into this matrix x1 x2 x3, where M is a 3 by 3 matrix. Then we shall to find out the eigen value of M. We shall to find out the eigen values of M. The answer, this is A, this is B, C, D. The Lx is equal to cross product of B and X. The cross product is equal to the determinant of I, J, K into the coordinate of B. Coordinate of B, this is the coordinate of B, that is 0, 0, 1, 0. 0, 1, 0 into X, coordinate of X equal to x1, x2, x3. That is cross product of B cross X equal to determinant of ijk 0, 1, 0, x1, x2, x3. That is equal to this. That is x3, that is this, that is we get cross product of B cross X into this form, or this is the transform of x3 0 k transpose. That is cross product of B cross X equal to this. We know that cross product B cross X is equal to, given that M into this is given. Suppose, and given that M is a 3 by 3 square matrix, suppose M is equal to C1, C2, C3, C4, C5, C6, C7, C8, C9 into M into this. This is equal to B cross C. B cross C is equal to x3 0 k, a column matrix, and this is M and this is X. By matching LHS and RHS, that is by matching LHS, that is LHS, this is x3, this is x3, x3 equal to C1x1, C2x2, C3x3. But x3 equal to C1 x1, C2 x2, C3 x3, which means that C1 equal to 0, C2 equal to 0, and C3 equal to 1. C1 equal to 0, C2 equal to 0, C1 equal to 1, we get x3 equal to 0 x1, 0, 0 x2, that is 0, 1 x3, that is x3 equal to 1 x3, that is we get 0, 0, 1. And on matching other 0 equal to this, we get M equal to this matrix. M equal to this matrix. That is M equal to this. Then characteristic equation of this M is equal to this. That is lambda into lambda square plus 1. That is lambda equal to 0, or lambda square plus 1 equal to 0. Lambda square equal to minus 1. Lambda equal to plus or minus I. Plus I minus I. That is lambda equals 0, plus I or minus I. Answer D is correct. 0, I minus I.